That's the thing. That's what happens when you, and I don't want to say like the wrong step. It's only wrong because it leads down a horrible path and will most likely make you more confused and give up because you feel like you're just like constantly going in circles. If you take the right step, it's like bang, bang, done. So when we look at this and we think about, again, this is another one of these problems where we have different variables, so we have to be very conscious of that. Okay, we have to be conscious of the terms that we can and can't do. Let's take a look at the quote-unquote the big picture, okay? When we looked at the big picture here, we said, all right, if I'm going to show these two things are the same, I've got two fractions and 0. The only way fractions equal 0 is if the tops equal 0. So that was kind of my mindset going into the problem, right? We said with this problem, how do I show that these two fractions are the same? Well, you can show that two fractions are the same if they have the same denominator and numerator. So let's make the denominators the same, and let's start with that. Those are the big pictures that we're talking about when we're doing verifications. Okay? Big picture here was, or is, this is one fraction. This is two terms, right? So, are you going to combine these two terms into one, or are you going to take this one fraction and split it into two terms? All right? Now, it's not always going to be an option to do that, but in this case we can. And if you're saying, no, that's not true, you said that it has to be like two things, a binomial on the top and then one term on the bottom. If I ever said one term on the bottom, I apologize. I didn't mean to imply that. But if the bottom is a product, as long as I keep that product together, I can decompose this fraction. Okay, so it doesn't fit the mold of that nice, clean, inverted triangle that I've been showing you. The bottom just has to be a monomial. And when I say monomial, that means no pluses or minuses. Right? If there's no pluses or minuses, I can move that denominator into both parts. So, I'm going to decompose this, I think. That's going to be my approach. Now it's two parts. And so is this. And the nice thing about these two parts is that in this fraction, the tangents will cancel. And in this fraction, the cotangents will cancel. We've got to be very careful with the variables involved, but it actually works out. So we have 1 over cotangent y, is that minus or plus? Ooh, wait a minute. I feel like that might be a typo. I feel like that might be a typo. I think it is. I think it is. Yeah. Yeah, because otherwise, I don't know. Yeah, that will work. My bad. My bad. And I'm not cheating to be like, no, there's, no, but yeah, I think that's a typo. Sorry. Just to be clear, if you're stuck in a problem, you can't be like, I'm making this a plus now. Like, I really do think that was intended. Anyway, 1 over cotangent is tangent, and 1 over tangent is cotangent, and now they're the same. Check mark. My bad. Yeah, that was supposed to be a plus. Otherwise, I don't think that would ever work. But the idea is still the same. And the idea is, are you going to create two terms from this one fraction, or are you going to create one fraction from these two terms? I chose to make two separate terms because they could start canceling these things out. Okay? Sorry about that. My bad, I'm not perfect, okay?